Hi, my name is Matt Holliday, and I'm excited to present to you today on the Go Developers Network. I'm going to talk about Go and Google's App Engine. I want to show you how to deploy an app, but really I'm going to show you some things about how to monitor and debug apps using some tools built into Google Cloud. So I'll say two words about myself. I've been programming for a long time, about 45 years. And if you look at this slide, I'm showing technologies that were current when I started learning. Now, it's changed a lot since then, and it's going to change in the future. 45 years from now, who knows what things are going to look like. So please join me and never stop learning. Okay, and as part of that, I'm going to mention one of my projects this year is I'm taking my class that I've taught in person and turning it into a series of videos. I'm putting them up on YouTube. They're rough drafts, and I'd love some feedback. Okay, enough about me. Now, App Engine's what's been described as serverless or platform as a service, right? You build your Go program to act like a web server, but it sits behind a load balancer / reverse proxy that Google owns that takes care of distributing traffic to your app, scaling your app, okay, and providing security. So you don't have to worry about terminating TLS. If you do want to have a custom domain name, you'll need to create your own certificate and import that into Google. And then Google also has a zero trust technology I'll show you in a minute called IAP. Okay, so there is one interesting thing about the way this works, and that is that you don't actually build your software and hand it to Google. When you deploy your app, Google takes your software up into the cloud, builds it, and containerizes it there. So it's a little different. To get started, you're going to need, of course, a Google project, okay? And you have to enable App Engine. Now, the button usually says something like Create an App Engine app. When you press it, you don't get anything because until you deploy your first app to the cloud, you can't see anything on the dashboard. Okay, so you're essentially enabling App Engine, and you have to pick a region for it. And then if you want to follow along with what I'm doing in these exercises, you'll want to also enable monitoring and cloud profiling. So I'm in my laptop, and the first thing I want to show you is the repo, mat4biz/go-gae-example, and I'm running everything today out of that. So everything I'm going to show you today is in that repo, and you can play with it for yourself. So what's in there first is a default application. There's an interesting thing about GAE. You can have several named apps, but the first one has to be default. And if you only have one app, maybe that's it. What I and some other people have done is we create a dummy app to put as the default app, and that's what I've done here. It's the simplest possible Go web server, right? It just starts up, listens with one route, and responds with hello web. I do want to point out that I look for an environment variable to get the port, because Google may want to tell me what port to use. Okay, but otherwise it's a very simple app, and you'll notice there's nothing Google specific about it. I'm not importing any Google headers to make the app work. Okay, I do, however, have to have what's called an app.yaml file, all right, because that's how I tell Google what software to take into the cloud and how to run it. Okay, now Google has this notion of runtime for App Engine because they also support languages like Python and JavaScript. And for Go, you have to say what version. Go 1.14 is current, 1.15 is in beta, so I'm going to stick to 1.14. Okay, I have to identify the instance class, and F1 is the smallest thing. It's the free tier. Okay, and my service, of course, again, this is the first service, so it's called default. And because I have 3 services that I'm building out of this repo, I'm going to tell it where to go find the software for the default one, which of course is command/default. All right, now, automatic scaling is the default, but I wanted to put in a thing here to say, hey, don't scale past 1 instance. And that's always going to be useful for the default app because it just sits there. But I'm also going to do that for the other apps just to make sure that, you know, for whatever reason, they don't get traffic and start chewing up a lot of CPU and money. And then the last part is actually what's important. This is where I tell it, hey, I want all my handlers to use HTTPS and redirect anybody that comes in with HTTP. Now, if I were building a real web app that had like an index page and static assets and CSS, I would add some more stuff in here, and I'll let you go look at examples in the Google documentation. All right. For what I'm doing here, very simply, I don't need that. And so I'm just telling it, hey, but do HTTPS for all the routes. And that's it. I don't have to worry about any other part of the security as far as the transport security. That's taken care of. So to deploy this app, I need to go to the command line. Okay, we're going to run a command from gcloud app deploy. And because I have more than one app.yaml, because I've got 3 apps in this directory, okay, I have to specify which one. So I'm going to hit that, and it's going to ask me, do I want to do this? And I'm going to say yes. And now it's going to start deploying, right? It's going to upload some files, and I'm going to wait. And so we're just going to have a little bit of time here, okay, until it happens. Okay, it's come back to us, and now we can see it updated the app, which is pretty easy because there wasn't more than one file to compile. It also updated the traffic split, so the traffic will all go to the new app, and we'll go see that. So if I go back over to Google, right, I have a dashboard for App Engine, and one of the things I can do is I can look at versions. So we'll come and look at versions, and it has the versions for default, the one that was already there and the one I've just added. So what I'll do now is I don't like to keep around old ones, so I'll delete it. And I'll just click on that one that's not has any traffic. And you'll notice I could also adjust traffic splits here. I could move traffic from one to the other or split the traffic between the 2 versions. In this case, they're identical. But I'm just going to delete the old version so it won't run anymore. Now, the other thing I want to show you, and you can't do this until you have your app up and running, is IAM is where we do identity management, and under there's something called Identity Aware Proxy. And if I go there, it allows me to put an added layer of security. Okay, so my apps have HTTPS, but they're open to the world unless I lock them down. And this is one way to do it. IAP is a, how satisfied? Yeah. IAP is a zero trust model. And so I'm going to go and take all of my apps and go down here and look at roles. And what I've done is I've added a couple of IAP secured web app users. And those are the only user IDs that can actually get into my app. Okay, which is really me. And I could add other people if I wanted to. In production, you wouldn't add individuals, you would add organizations. In other words, you would create an account in your project for your client microservices, the ones that talk to you, and you would add them in here, and then they would be able to access your app, but it's still on the internet and other people can't. So now we'll look at one of my apps, and I'll go over here and look at the services. It gives me a list of the services that I've got running, and if I click on the To-Do app, it's going to take me there. Now, I need to give it something more. My To-Do app, it doesn't really do to-dos. It goes out to a server from a company called typico.com. They run a server that just serves up REST for a fake to-do app that allows you to do some testing. Okay, so my little proxy web server, if I type in the number of a to-do here, it's going to go out and get it from Typico, decode the JSON, and turn that into a web template. It's not very exciting. But what it is going to do when it returns, it has the information that came back from Typico, and it has one more thing, because I'm putting a trace ID into it, right? Now, this is for logging, or at least for me it's for logging. If I go and look at the log viewer, and I'll update this, right? So down here is my latest log, and if I go look at that, I get a log from App Engine every time there's a request. It's got the route, it's got where it came from, the type of browser, how long it took. It took a while because it needed to wake me up, okay? How many bytes were returned, and so on. Okay, fine. Now, the log also has in it this trace ID, okay? And that trace ID comes in a header. If I were to look at the header of the request, we're going to find it there. And what I can do is pull it out and use it in my own logs. And I'll show that it's an easy way to correlate the logs. In fact, let me start there. So if I go back to my To-Do app, right, I've selected this trace ID. I go to the log viewer, and I can just type it in the search field. And now it's only going to show me logs with that trace ID. It's random enough, I'm not going to get any other junk. It's not very exciting to have 2 logs. But if I had a bunch of logs on a request, and I have a lot of requests per second, then suddenly being able to type a trace ID and correlate them is very convenient. So how do I make that work? Well, I'm going to go look at the handler for my to-do app, right? And it has some other stuff in here. It has the structure of the to-do, and it has the code to go out there and, basically, I'm doing a request to the Typicode server in my server, and I get back the JSON, right, which I decode, and then I put that into a template, right, and I'm just adding one more thing to my template, which is this trace ID, which is why it shows up in the web. Now, if I were doing a REST API, I could send it out in my REST API as part of the data, or maybe even metadata, or I could make it an attribute from a GraphQL data structure. I've done that. But in this case, I'm just showing it on the web. And if I look at how that comes, right, so there's a standard header, and I say standard for Google App Engine, X Cloud Trace Context. That header is going to be in every request, and I have a little function here that I go and take the request, find the header that matches that key, pull out the data. It's a string. Now, it turns out in practice it has this trace ID slash and some other stuff. And I don't care about the other stuff, so I just split it at the slash and take the first part. And that's always going to be safe. Even if the split is just one item, I can index the 0th part of that. So it's always safe. I get the trace ID, and now I just come down here and put it in my logger. Now, I'm using the standard library logger, so I'm just taking the writer from the default logger and making a new logger around it so it goes to the same place with the trace ID and these flags that say, hey, put this into it and put it, in front of my other stuff, but after the date and time. All right. And now every time I print a log, and I've got some logs in here for errors, but down here I've got a log. This is the one you saw. When that log prints out, it's going to have the trace ID in it. Now, in production, I probably wouldn't use the standard logger like this. I would use some fancier logger that probably put out JSON, right? And then the trace ID would be a property of that JSON. And again, that's fine. When it gets to Stackdriver, where am I? Right? If I had a log with JSON stuff, I would see a field here, JSON payload, and I could look in it. But I don't even need to. Once I type this ID on the search bar, it's going to find it regardless of where it was, whether it was in the text or in the payload from Google's logs or the payload from one of mine. So there you go. That's an easy way to put the logs together. It's very convenient. Now there's something else going on in this app, and I'm not going to dig into it, but if you go back and look through here, I have a bug, and my bug is going to cause this app to leak Go routines. So the question is, how do I see that? And I can do that by going over to the profiler. All right, so GCP has a profiler built into it. I've picked my app, the to-do app, and I've asked it to go look at, the drop-down says threads, but when you look down here it says Go routines. And what's interesting is, unlike the built-in pprof, this one has a heat map. So I'm looking at a heat map, and this number over here is going to grow. If I were to run traffic against this, I'm not right now, it's just going to keep growing. I'm going to see more and more Go routines. And they're basically sitting, if I look at this stack, they're sitting on a polar. They're sitting waiting to read something. Well, okay, why? Well, because I didn't properly close them in my app. Okay, so if you've taken my class, you know the number one way you leak memory in Go is to leak Go routines. And one of the ways to leak Go routines is to leak sockets. Right, so if you don't properly close the response body in your handler, you're going to leak sockets and they're going to show up here. And the right way to do this is not to wait for your app to crash and go figure out why. Okay, you build your app and you test it, and part of testing is load testing. So you run some traffic against your app and you look at it in a tool like this and see, hey, do I have a number of Go routines that's just growing? Because if it's growing and not shrinking, or it grows and then you stop traffic and they just sit there, okay, you have a problem. And this is how you find it. Now, how did we get this part? And to get this part, we need to add something to our program. So I'm going to go back into my to-do app, and I have another file called monitoring. And let me actually go to main first. In main, I have a little bit of code where I call init monitoring. That's a function I wrote. Okay? And if I skip back and look at it, this is where I do in fact have to start calling a Google API. Right? I'm going to import the profiler API. Right? I'm going to go out and use a couple of environment variables to find my project and my service, put them into a config, and then I pass my config to profiler.start. And that's all I have to do. That's enough to connect my App Engine app with Stackdriver so that Stackdriver can get profiles out of my app. Okay, and we can look at them. We can look at the GoRoutine one, and later in a couple minutes I'll show you how to look at CPU time. But this is all I had to do. But once I do this, now I have some Google specific code in my app. Right, so I want to go look at yet another app real quick. So I want to go back to my services, and I've got another one here called sort, and actually I think it's already open. All right, and sort is actually an animation of sort algorithms. So I'm going to hit insertion sort, and again this is going to take just a little bit of time. The server may be asleep, and this is slow on the kind of machine I'm running, but it's going to animate the insertion sort, right, from top down. So if you start at the top, you've got the unsorted array, and every row shows a step as we work our way down until we end up with a sorted array. Okay, this is the insertion sort, for example. I'll let it finish and we'll run another couple. Right? And I've got also, if you look at the code, you can say whether it should loop the animation or not, and you can actually set a delay between frames. But right now I'll just run insert, it's done. Right? I've got a quick sort. This is not the fast quick sort, so it's going to take a little bit of time. And then we'll run more and more after that. And I'm doing this so I can run a bit of traffic and we can measure it. So here's quick sort. It works a little differently. It's doing sort of blocks as it does partitions and chunks and stuff. Okay, and this one works from the top right down to the bottom left. But we'll see as we go, we get more and more sorted, and we're almost there. There we go. That was the not so fast quick sort. I've got another variation that's much, much faster on an array like this. We'll run that real quick, and boom, it's done. Right? That was the quick sort. Okay, so why am I doing this? Well, I can go look at the traffic. If I go back to my dashboard, so this right here gives me one way of looking at traffic. Okay, I can see that I've got requests in my app. I can drill down a bit more than that, and I can do that with something called the Metrics Explorer. Now, this works because there's some metrics. Google does have some metrics of their own. So I can go pick a Google one that says, well, how many requests went into your App Engine app? But I've also defined a couple of custom ones to show this, and we'll show you how we set it up in the code in just a sec. But here we go, and I have them broken down by route. So how many inserts and qsorts and qsort3 and so on. I didn't run a lot, so it's not terribly exciting. Okay, but I've picked my metric. I don't think it'll pop up. Yeah, well, it's very small. You probably can't read that. And I've also said, hey, group it by route, and I'll show you how to do that. But what I've also done is created a custom dashboard. And again, I've done the custom dashboard with my custom metrics. So I can see, for example, requests per second. And it's just a little bit behind the time. It takes a little bit of time for the metrics to get out of the app and through Stackdriver. So they'll show up here in a sec, right? I've got one for requests per second, and I've got one that shows the P99 latency. Okay, so where did those come from? And the answer is they came out of custom metrics that I built into the program. So if I go look at the sort program, right, I've got my init monitoring. It's a bit more complicated. So first, I've got several more things I'm importing. There's a package called OpenCensus, and it provides a way of defining custom metrics, and it has tools to export them to Stackdriver and other providers. Okay, so I've imported those, and I'll use them. Okay. Now, in order to group my routes, I have to define a key to do that. So I've got a variable that represents the key for the routes, and then I've got a couple of variables that I'm actually going to increment. That's where I'm actually going to peg the stats as I do requests. Fine. Right. The part up here is the same where we start the profiler. And now we get into the code that's new. The first thing I've got to do is actually create a new key for the route. I'll call it tag.newKey. And a tag is something I'll apply to metrics. I'll show you that in a minute. And then I've got a create a couple of views. Now, the view is the way we export the metrics. It encapsulates one of these counters and says how to interpret the counter. So the request view encapsulates the request counter, okay, says it's going to be a count, so we're going to just sum them up. And also I've got a tag here with my route key so I can group them by route. The request time view is a little different because it has a distribution. And so this allows me to say, hey, I'm going to measure it with some time intervals, put them into buckets, and deal with it that way. So I'm not just adding up the time total, I'm measuring it in terms of, well, how many were at 1 second and 2 seconds and so on. Now, I would normally do this at the level of millisecond, all right? But this animation app and the very small instance I'm running on, it's not very quick. And again, I can break those down by routes. So I've got the route key again here, okay? In order to use the views, I have to register them. So I call view.register and pass in my two views, okay? And then I need an exporter. The exporter is the part that actually is Stackdriver specific. This is where the internal stuff of OpenCensus gets turned into something that Google can handle. So I go and create an options with my project ID. And my project ID, again, I got it up here by looking at the Google Cloud Project Environment variable. Right? So I call for a new exporter. I register my exporter. And then the last thing I do is I set the reporting period. And it just says, how often should OpenCensus try to push metrics to Stackdriver? And 60 seconds is a pretty typical number. Great. So now I've defined my custom metrics, but they don't do anything yet. If I want to do something with them, I have to use them when I process requests. So I'm going to go over and look at my handler code, and in there I've got a chunk of middleware. Okay. Now my middleware is doing some other stuff, right? I'm getting the route from the path, and I'm putting it into the context. So the way when you tag a metric, or excuse me, when you peg a metric, you'd use the context, and to put a route tag on it, I need to modify the context, right? So I call tag.new, which is actually going to return a context. I use the incoming request context, and I'm adding to it this route key that says, hey, you know, find the route, which I've already broken out from the URL, and mark it with this route. So that way they can be grouped that way when they're displayed. Okay. The trace ID and logger stuff we've seen before. I've also got a little trick called a counting writer that lets me figure out how much output was sent back in the response. Not very exciting. Okay. In order to do time, I've got to start a timer. So I go and get time.now, right? And then I do my serve HTTP, and then I calculate how much time was elapsed, right? So I'm going to peg here the count of requests with stats.record. I pass in the context, and I pass in this variable that's the measure of the number of requests. Okay, and again, that was tied to a view and tied to an exporter, right? When I calculate my time, usually I resolve it as milliseconds. Now, because here I know that I'm really slow, I'm going to divide by 1,000 and report it in seconds. This is just weird, and I'm doing it for this example app. So I do a stats.record, and this time I'm adding something to request time. Again, this is going to be put then in the request time view and shown as a distribution. All right, latency. And then I can look at, you know, what's the average latency or the P95 or P99 latency. Great. So this middleware gets run every time I run a request, regardless of, you know, which type of sort algorithm I'm running against, right? We'll find it, pick it out, put in the tag, record the metrics about this query, and they'll build up. And again, that allows me to go back to this dashboard, for example. And there's actually a little button here. If I turn it on, it'll start running in real time. Okay, so it shows me this most recent stuff, right? How many of each kind and so on. And some latency stuff over here. Pretty slow because, you know, my app was asleep and had to start up. And these sort algorithms are not really fast on the little instance I'm running. Okay. Now there's one more thing I can show about this app, and that's the CPU profiler. So I'm dropping into the profiler again. And in this case, my drop down is for CPU time, and it's the sort app. And if I look at this, you know, over here, there's just a bunch of background junk. This stack over here is all the stuff related to serve HTTP. And it gets broken down right about here based on the route. You know, if I call the insertion sort, it's pretty slow, or I spend a lot more CPU time there compared to like a quick sort, or particularly the fast quick sort, right? So I can actually see the speed of my sort algorithms that I'm animating by how much CPU they're consuming, and particularly the relative amount of CPU. The fast quick sort's much faster than the others, and they're much faster than insertion sort. Okay, right? And you can do other things in profile. I'm not going to look at memory right now, but you can look at memory with it. And again, all I had to do for profiling was to make one call to start the profiler. For the custom metrics, I'm using the OpenCensus package. I had to do a bit more work, but it's pretty straightforward. And once I've got some of that set up, if I want one more metric, the delta is pretty small, right? You just got to figure out, okay, where am I going to peg that metric in my program? But having that is very useful, right? Again, I could probably create this dashboard using metrics from Google. But if I also want metrics like how many queries do I send to other microservices, or how many times do I go to Redis, or how many errors do I have going to the database, I'm going to want custom metrics for that. And I find the best way to do that is to use OpenCensus. There is also a way to do log-based metrics. I don't like them. I think they're fragile, because if somebody changes the text of your log, well, maybe it doesn't match your expression anymore when you're trying to filter the logs for a log-based stat. So I think the metrics are a better way. Okay. And of course, we have the log viewer, and I can change the log viewer to show me the sort app, right? I can just go and say instead, I could have told it all the apps, but right now I'm just saying, hey, look at one or the other. And here are my logs from, running like quick sorts. And again, they've got trace IDs, and I've got trace IDs here. Okay. Now, I didn't put a trace ID in the image that I displayed in the web browser. That's not very convenient. But if I were doing some sort of REST API again, I might. Because if somebody comes to me and says, hey, I had this problem, and here's the trace ID from your response, I can take the trace ID, throw it in the log viewer, and immediately find the logs and see, oh yeah, well, it didn't connect to the database properly when it tried to handle your request, or it timed out or something. Okay, so these are some techniques for debugging apps in Google App Engine, and I've also showed you how to actually deploy an app and manage it. As I wrap up, I just want to point out I've also got, I have some other repos for classes that I teach, but I've got a repo with Go resources for learners. So it's got a collection of some books and articles about Go and videos, particularly videos from old GopherCons, and a few videos and articles about building software in the cloud and so on, and software development techniques. So it's interesting stuff, okay? And then finally, I just want to say thank you for your time. And here's some contact information if you want to get a hold of me, right? And if you want to search for the videos, I either had the playlist earlier, or you can search on this little funny little tag here. You'll have to hold down the Option O to spell it right. Anyway, again, I'm very glad to have this opportunity to present to the Go Developers Network, and I hope you enjoyed it.